We're given a table with reduction potentials for each of these reactions, and we're asked to find some different things. The first thing that I did with the reduction potentials that we're given is I also made the I can do this. For video 1, we're given a table of half reactions and their reduction potentials. The first thing that I did was also create their oxidation potentials from the reduction potentials, which is just the inverse, which is just the negative of the reduction potentials. The first thing that we're asked to find is the strongest reducing agent, which is the one being oxidized, which is the one that's most apt to lose electrons. So we can look at our table and we see that D minus has the highest oxidation potential. It has the highest positive number for the oxidation potential, so we know that that one is the strongest reducing agent. The strongest oxidizing agent, which is the one being reduced, which is gaining electrons, which is the one most apt to gain electrons, is A3+. And we know that because the reduction potential is the highest positive reduction potential from the table. To find what species can be spontaneously oxidized by B2+, we know that spontaneous means that the cell potential will be positive number. Oxidized is losing electrons, so we know that the reduction potential is 0.60 for B2+. So whatever oxidation numbers we can add to that 0.6 and come out with a positive cell voltage or cell potential will mean that these species can be spontaneously oxidized by B2+. So we find that the oxidation potential of C+ is positive 0.21, and the oxidation potential of D- is 0.138. When you add both of those respectively to 0.60, you get positive numbers. So we know that C+ and D- can be spontaneously oxidized by B2+. We use a similar process to figure out what can be spontaneously reduced by C+. The oxidation potential of C+ is 0.21, so whatever reduction potentials we can add to that number, that comes out with a positive number. We know those species can be spontaneously reduced by C+, so we have B2+, the reduction potential is 0.60, which is just found from the table here, and then A3+, the reduction potential is 1.47, so when you add those respectively to 0.21, you come out with positive numbers, so you know that B2+ and A3+ can be spontaneously reduced by C+. To find the reaction with the highest voltage, you add the strongest oxidizing agent and the strongest reducing agent, which we identified that the strongest oxidizing agent is A3+ with a reduction potential of 1.47, and the strongest reducing agent is D- with an oxidation potential of 1.38. To write out the equation, the reaction, we have the half reactions that are given from this table, but we see that A3+, this reaction has 2 electrons, so we need to multiply this top reaction by 2, and then the net reaction, once you cancel the electrons out, you have A3+ plus 2D- yields A+ plus 2D, and then to calculate the cell potential or the cell voltage, we have the reduction potential and the plus the oxidation potential, which is 1.47 plus 1.38, and that equals 2.85 volts.